Every James Webb Space Telescope discovery explained. Yeah, you heard that right. We're diving into all the revolutionary revelations from humanity's most powerful eye in the sky. This golden mirrored giant has spotted galaxies that shouldn't exist, captured light from the dawn of time itself, and detected molecules in alien atmospheres that could signal life. But here's what's really wild. Even Neil deGrasse Tyson, the master of cosmic cool, admits Webb's findings have left astrophysicists completely stunned by what they're seeing. The telescope designed to confirm our theories has instead sparked the biggest scientific upheaval in astronomy since we discovered the universe was expanding. Today, we're unraveling every shocking discovery that's forcing scientists to question fundamental assumptions about reality itself. So picture this. You spend decades building the most sophisticated space telescope ever conceived. You launch it 1,000,000 miles from Earth, and the first thing it does is basically tell physics to take a seat. That's essentially what happened when Webb started spotting massive, fully formed galaxies existing just a few 100 million years after the Big Bang. Now, to put that in perspective, and trust me, I'm going to channel my inner Charles Liu here. That's like finding a fully grown oak tree that claims it sprouted yesterday. The University of Missouri team identified 300 objects that were brighter than they should be, and some of these celestial rebels are sporting masses that would make our Milky Way look modest, all while being, cosmically speaking, basically newborns. According to our models, the early universe should have been like cosmic kindergarten, small, simple structures, slowly learning how to become galaxies. Instead, Webb found what astronomers are calling universe breakers. Galaxies so massive and mature, they literally challenge our understanding of cosmic evolution. The controversy here is absolutely delicious. Some scientists are suggesting we might need to completely rethink our galaxy formation models. Others are whispering about exotic physics. Maybe dark matter behaved differently back then, or perhaps there's some unknown force we haven't accounted for. As astrophysicist Charles Liu has noted in his discussions about cosmic evolution, we might need entirely new physics to explain what we're seeing. Alright, real quick. If you're enjoying this cosmic crisis of confidence, smash that subscribe button and ring the notification bell. Trust me, with the rate Webb is demolishing our assumptions about the universe, you're going to want to catch every update. Plus, stick around, because later, I'm going to reveal something about interstellar visitors that'll make you rethink everything you know about our cosmic neighborhood. Speaking of cosmic mysteries, let me tell you about the weirdest house guest our solar system has ever had. 3I/ATLAS is just the third ever object found drifting through our solar system that is believed to have originated from around another star, and Webb just caught it doing something nobody expected. This interstellar comet, and yeah, it's from another star system entirely, is hauling through our neighborhood at over 130,000 miles per hour. That's not a typo. This thing is moving so fast that if it were a bullet, it would circle the Earth 5 times before you finish saying, "Holy cosmos." But here's where it gets fascinating. The comet appears to be unusually rich in carbon dioxide. Now, that might not sound like much, but it's like finding out your neighbor's cat speaks Mandarin. It tells us something fundamental about where this thing came from, is very different from what we anticipated. The trajectory of this cosmic wanderer suggests it comes from the Milky Way's thick disk of stars, a region of our galaxy much more ancient than the thin disk where our sun was born. This frozen time capsule has been cruising through the galaxy for potentially billions of years, carrying chemical signatures from parts of the galaxy we can only dream about visiting. Now let's talk about Jade's GSZ 14-0, a galaxy that's become the poster child for Webb's ability to shatter records. This galaxy has a redshift of 14.32, making it the current record holder for the most distant known galaxy. We're seeing it as it existed just 290 million years after the Big Bang, when the universe was a mere 2% of its current age. What makes this discovery so revolutionary isn't just the distance. The source is found to be over 1,600 light-years across, proving that the light we see is coming mostly from young stars and not from emission near a growing supermassive black hole. This much starlight implies that the galaxy is several hundreds of millions of times the mass of the Sun. How can nature create such a bright, massive galaxy in less than 300 million years? That question is keeping astrophysicists up at night. Given the observed brightness of the source, we can forecast how it might grow over cosmic time, and so far, we have not found any suitable analogs from the hundreds of other galaxies we've observed at high redshift in our survey. In other words, this thing is genuinely unique. It doesn't fit any of our models or predictions. Remember everything you learned about black holes needing billions of years to grow supermassive? Yeah, well, Webb just caught some that apparently skipped the line entirely. In May 2024, the JWST detected the farthest known black hole merger. Occurring within the galaxy system, ZS7, 740 million years after the Big Bang, this discovery suggests a fast growth rate for black holes through mergers, even in the young universe. To understand how extraordinary that is, imagine finding two sumo wrestlers at a toddler's birthday party. These things should barely exist, let alone be massive enough to merge. This discovery suggests black holes might have had a secret fast track to growth we never knew about. Maybe they started big, really big, through something called direct collapse, where massive gas clouds skip the whole star phase and go straight to black hole status. It's like going from crawling to running the Olympics without learning to walk. Neil deGrasse Tyson put it perfectly during one of his talks. There was a gap in our telescopic space-time continuum where nothing on Earth could get high-quality data from that early on in the universe. Webb filled that gap and found phenomena that are forcing us to reconsider basic assumptions. Alright, quick pause for our second call to action. If you're digging these revelations, drop a comment below with your favorite Webb discovery so far. And hey, subscribe if you haven't already. Because trust me, the discoveries coming in 2025 are going to make these look like child's play. Now let's talk about something closer to home that's equally fascinating. Webb's been checking out exoplanets with unprecedented detail, and what it's finding is revolutionizing our understanding of other worlds. Astronomers using the NASA/ESA/CSA James Webb Space Telescope have captured compelling evidence of a planet with a mass similar to Saturn, orbiting the young nearby star TWA7. If confirmed, this would represent Webb's first direct image discovery of a planet, and the lightest planet ever seen with this technique. But it gets better. Remember all that hype about finding Earth 2.0? Well, Webb's been studying the TRA-PPIS T1 system, and the results are complicated. The exoplanet TRAPPIST-1d intrigues astronomers looking for possibly habitable worlds beyond our solar system, because it is similar in size to Earth, rocky, and resides in an area around its star where liquid water on its surface is theoretically possible. But according to a new study using data from the NASA/ESA/CSA James Webb Space Telescope, it does not have an Earth-like atmosphere. It's like ordering 7 pizzas and getting 7 completely different cuisines. Surprising, potentially disappointing, but definitely educational. Here's something that'll cook your noodle. Everything Webb sees is ancient history. As Tyson explains, by the time it reaches us, it's infrared. Light from the early universe has been stretched by cosmic expansion. The telescope is quite literally a time machine, showing us baby pictures of the universe when it was just 300 million years old. That's like seeing a photo of your great-great-grandparents as infants. Webb uses this phenomenon to see things Hubble never could. While Hubble sees invisible light, like our eyes, Webb sees in infrared, heat radiation. This means it can peer through cosmic dust clouds that would blind other telescopes and catch light that's been stretched by the universe's expansion for over 13 billion years. It's like having X-ray vision, night vision, and a DeLorean all rolled into one golden package. Now here's a story that shows how Webb isn't just about pretty pictures of distant galaxies. It might literally save civilization one day. Asteroid 2024 YR4 was discovered on 27th December 2024. As of 10th February 2025, it has an approximately 98% chance of safely passing Earth on the 22nd of December 2032. Before you start stockpiling canned goods, let me ease your mind. That 98% safe passage is pretty reassuring. But that 2% uncertainty? That's where Webb comes in clutch. The telescope used its infrared superpowers to measure the asteroid's actual size, something ground telescopes struggle with. See, from Earth, we can only see reflected sunlight, which tells us brightness, but not size. A small disco ball and a big lump of coal can look identical. Webb is able to study the infrared light, heat, that 2024 YR4 emits rather than the visible light it reflects. Why does size matter? Well, the hazard represented by a 40-meter asteroid is very different from that of a 90-meter asteroid. We're talking about the difference between a really bad day for one neighborhood versus evacuating an entire metropolitan area. One of Webb's most visually stunning discoveries isn't about the edge of the universe. It's about stellar death and rebirth in our own galactic backyard. The NASA/ESA/CSA James Webb Space Telescope has revealed new details in the core of the Butterfly Nebula, NGC 6302, showing us cosmic recycling on an epic scale. This dying star is throwing an absolutely spectacular tantrum, ejecting material at velocities that would make our fastest spacecraft look stationary. But here's the beautiful part. This stellar death creates the ingredients for new life. The heavy elements forged in this star's core and blasted into space will eventually become part of new stars, new planets, and potentially new civilizations. Carl Sagan's famous "We are all star stuff" isn't just poetic license. Webb is literally documenting the process in real time. Let me blow your mind with something that doesn't get enough love: the absolute insanity of Webb's engineering. As Tyson noted, so much had to go right to deploy this telescope. This thing had to unfold like the world's most expensive origami project, with over 300 potential single points of failure. One cable snaps, one motor stalls, one heat shield fails to deploy, and we've got a $10 billion floating paperweight. The sun shield alone, 5 layers of material thinner than tissue paper, had to unfold flawlessly to protect the instruments from solar radiation. The temperature gradient between Webb's hot and cold sides, about 600 degrees Fahrenheit. That's like having a blast furnace on one side and liquid nitrogen on the other, separated by material you could literally poke your finger through. And get this magnificent twist. Even though the telescope only met the specs, it exceeded all our expectations. It's tracking objects at twice the design speed, operating longer than planned, and seeing deeper than anyone dared hope. It's like ordering a Honda Civic and discovering it can transform into a spacecraft. Perhaps Webb's most fundamental contribution isn't any single object. It's completely redefining our cosmic census. Remember when Hubble did its famous deep field and we realized the universe had way more galaxies than we thought? Well, Webb just made Hubble's revelation look like a rough draft. The discovery of JWST 14-0 and its cosmic siblings suggests the early universe was a much more happening place than we imagined. All of these observations together tell us that JWST 14-0 is not like the types of galaxies that have been predicted by theoretical models and computer simulations to exist in the very early universe. This isn't just about bigger numbers. It's about fundamental questions. If galaxies formed faster and earlier than our theories predicted, what does that mean for dark matter, for cosmic inflation, for our entire timeline of cosmic history? Charles Liu, in his work on galactic evolution and star formation history, points out that these discoveries might require us to develop entirely new frameworks for understanding cosmic structure formation. Now, let's address the cosmic elephant in the room, the search for life beyond Earth. Webb wasn't specifically engineered as an alien hunting machine, but it's turning out to be remarkably adept at sniffing out potential biosignatures. Webb uses infrared light and spectroscopy to detect specific molecules in alien atmospheres: methane, oxygen, water vapor. Webb can identify them all in the atmospheres of worlds light years away. But here's where it gets intriguing. We're finding these chemicals in unexpected places and not finding them where theory predicted. The real controversy brewing in the scientific community? Some researchers suspect we may have already detected potential biosignatures, but are being extraordinarily cautious about announcing them. Others argue we're too eager, potentially mistaking complex chemistry for biology. It's the ultimate scientific tension: the desire to make history's greatest discovery versus the fear of making history's most embarrassing mistake. Here's something that'll scramble your cosmic eggs. Webb researchers discovered a lensed supernova and confirmed the Hubble tension. Now, Hubble tension isn't what astronomers feel during budget meetings. It's the disturbing fact that different methods of measuring the universe's expansion rate give different answers. It's like having two perfectly accurate rulers that disagree on how long a meter is. This discovery matters because it suggests something fundamental about our understanding of cosmic expansion might be off. Are we missing some exotic form of energy? Is there new physics at play? Webb's precision measurements are making this problem impossible to ignore, forcing cosmologists to confront uncomfortable questions about the very fabric of space-time. Looking ahead, Webb is just warming up its infrared sensors. The telescope has sufficient fuel reserves to operate for 2 decades, double its planned mission duration. That means an entire generation of discoveries we haven't even conceived of yet awaits us. Upcoming observations include monitoring more interstellar wanderers, hunting for the universe's very first stars, the so-called population 3 stars that have never been directly observed, and potentially answering humanity's ultimate question: are we alone? But here's what really gets my neurons firing: the questions we haven't thought to ask yet. Every revolutionary telescope in history has revealed phenomena nobody predicted. Hubble showed us dark energy. Radio telescopes unveiled pulsars. And Webb? Webb might reveal something so fundamental, so paradigm-shifting, that we don't even have vocabulary for it yet. So what's the takeaway from every James Webb Space Telescope discovery? The universe is stranger, more complex, and more awe-inspiring than our wildest scientific dreams. We've learned that galaxies can form with shocking speed, that visitors from other star systems carry unexpected chemical calling cards, and that our cosmic models need serious renovation. We've discovered that scientific progress isn't about confirming what we know. It's about discovering how wrong we were in the most spectacular ways possible. As Neil deGrasse Tyson eloquently puts it, we're not just editing textbooks. We're writing entirely new chapters in humanity's cosmic story. But perhaps most importantly, we've learned that we're barely scratching the surface. Every answer Webb provides generates a dozen new mysteries. Every image captures phenomena we don't understand. We're not just observing the universe anymore. We're engaged in an epic conversation with cosmos itself, and it's telling us stories beyond our imagination. All right, space fans, if these discoveries have expanded your mind faster than the universe itself, you know the drill. Hit that subscribe button like a meteorite hitting, well, hopefully missing Earth. Ring that notification bell, because Webb drops revelations faster than you can say Cosmological redshift. Drop a comment below sharing which discovery rocked your world the hardest. Was it those impossible infant galaxies? The carbon dioxide-rich interstellar visitor? Or maybe the fact that we're literally using a space telescope for planetary defense? And hey, if you enjoyed this journey through the cosmos, share it with that friend who still thinks astronomy is just about naming constellations. Remember, we're living through astronomy's golden age right this second. Our grandchildren will study these discoveries in whatever neural implants pass for textbooks. So stay curious, keep your eyes skyward, and remember, somewhere out there, 13 billion years ago, a photon began an epic journey just so Webb could catch it and absolutely wreck our understanding of everything. Until next time, this is your cosmic correspondent signing off. Keep your eyes on the stars and your feet on the ground, unless you're an astronaut, in which case, do whatever NASA tells you. Peace out, Space Cadets!